Hello everyone, welcome to my YouTube channel Learn Loom. I have recently cleared the Microsoft Power BI Data Analyst Associate certification, and this channel is my way of sharing what I have learned during my PL300 certification. Here I aim to break down simple and complex Power BI topics quickly and in details using presentation and examples. Join me for a simplified journey into the world of Power BI. Today I'm about to kick off my first video on DAX, the trickiest part of the Power BI. I'll walk you through every DAX function with a simple examples and easy to remember one-liners. Before learning DAX, you must have a foundational knowledge of Power BI basics, SQL basics, Microsoft Excel basics, and relational database management system. So what is DAX? So DAX is a formula language by Microsoft for Excel, Power BI, and other data analysis tools. It is designed to work with the tabular data, which is organized in tables, columns, and rows. Basically, DAX is your go-to language when you are dealing with the structured data in these applications. How is DAX useful in Power BI? DAX allows user to create a complex calculation. DAX is essential for defining relationships between these tables. Furthermore, DAX is divided into DAX function, DAX statements, and DAX query. So DAX has a varieties of function types, and we will begin our exploration today by focusing on aggregation functions. In simple terms, aggregation functions in Power BI are like wizards that help you crunch numbers easily. They add up, average, or count your data, making it simpler to understand and analyze. These functions are like magic tools that quickly summarize lots of information for you. Let's begin by exploring the first aggregation functions, approximate distinct count. This function estimates the count of unique values in a column by balancing speed and accuracy. It works on any type of data. So you see the syntax, it's a function takes only one argument, which is a column name. So let's take an example to understand this function more clearly. Imagine you have a big pile of different toys and you want to know how many unique types there are. Now, if you are in rush and don't need to be super exact about the count, you might just take a quick look and make a good guess. That's a bit like what approximate distinct count function does. So in real time, whenever you are dealing with the large and complex data and you need to know a rough figure of a distinct count, you can use this function instead of distinct count. Next, we are going to see average A, average X function. So average and average A has a single argument, which is a column name, and average X has two arguments, which is table name and expression. So average, it calculates the average of a column, but with the catch, it only considers numeric data. Now let's meet average A. This function is a bit more inclusive. It computes the average of a column as well, but there is a twist. It includes the non-numeric value in its calculation, like a boolean. Last but certainly not least, we have average X. This function is like a master of averages. It doesn't just settle for a single column. Instead, it evaluates an expression for each row in a table and then averages out the result. It is a powerful function when you want to perform a calculation row by row and then find the average of those calculation values. For better understanding, let's watch a short demo in Power BI on these functions. So this is my data view in which there are six columns: ID, name, subject, marks, pass, date under the class table. Let's switch to report view, and here if you see I have created the measure with the name of a average underscore marks. I'm using average function and using a marks column from class table inside the function single argument, and if I run this I get this output which is the average mark of 10 student. So as we saw in the presentation, this function doesn't support the non-numeric value. So let's try the Boolean value here. It's a pass in the table. If you see, it's a true and false. And let's try to run this. If you see, it doesn't support the Boolean value, it is showing the error. So if we go the second measure, which is average pass, in which I have used the average A function with the Boolean types, Boolean column, which is pass in the class table. This shows 80% students are pass. If you see here, there are one false here and the second false here. It means like 20% are fail, 80% is pass. So let's go to our third measure, which is expression average x, in which I am taking two arguments. First is the table name, which is class, and second is a mark column from the class table, and I'm adding 20 marks for every student. So basically what this expression gonna do, it's gonna add 20 marks for every student, and it gonna take an average of 10 students after implementing this expression. So it is also showing the successful result here, which is a 82.40 average marks. In this slide, I have added the measures I created in Power BI along with that picture showing the results, and I will put the links to presentation file in the description. I use this references to make this video, and I hope you find this video helpful, and in the next video we will explore more aggregation functions. Thank you.